This is a continuation of the SAT 3 worksheets. I'm on problem 16, so if you'll find that problem, and it says the function f is defined by, and it gives us this equation. If f of b equals f of 0 and b is greater than 0, what is the value of b? So this is saying whatever you get when you plug in a b is going to be the same answer that you get when you plug in a 0. And we know that this answer has to be greater than 0. So the only number we know at the moment is that we need to take this problem and replace the x with 0. So work this out. Absolute value of -2 is a 2. So our answer is 7. On the previous problems that you did, you filled in tables for absolute values. So we could add these numbers to a table. We could say when we plug in a 0, we get a 7. Well, what they're asking us is, what would b need to be to also give us a 7? So notice how I plugged in, or this is on the f of x side, so I need to plug in the 7 in for f of x this time and solve for the x. So we're going to subtract 5 to isolate the absolute value, and then I need to solve my two equations. You always set it equal to the positive of this and then the negative of that. So I would add 2 to both sides. I get a 4 here. Add 2 to both sides, and I get that 0. So there's the 0, and look, the other answer is 4. So I just found the other thing, the other solution, the other x that when I plug it in would give me a 7. So that's how number 17 will also work. So stop the video and go ahead and go work number 17. Here is the answer to 17. So the first step, we're still using this equation, is to plug in a 1 where you see an x, so 1 minus 2, and then plus 5. 1 minus 2 is in the absolute value bars, so you get a -1, but the absolute value of -1 is 1. So 1 plus 5 is 6. So we now know that when you plug in a 1, you're going to get a 6. So we want to know what else would give us a 6. So take 6 and set it equal, replace the f of x with the 6, and work out the problem. And work it all the way down. You end up getting an x minus 2 equals a positive 1 and an x minus 2 equals -1. Add 2. You get a 3, add 2, you get a 1. This one is that one, and then the other answer is 3. So the rest of the page is done that exact same way. You get a different function to use, and you can just do it exactly the same way we did those other problems. Now let's go to the next page. Adding fractions. These are called rational problems. We're adding rationals. Just like when you learned how to add fractions a long time ago, you do the same thing even though there's variables. You still need to find a common denominator. So you look at the two denominators and say to yourself, what's in common? Well, there's nothing in common. And a lot of times when there's nothing in common, the only thing you can do is multiply the two numbers, and that would have to be your common denominator. So we're going to say our common denominator is a 3x. So you need 3x in both denominators. Then to find the numerator, you ask yourself, what did I need to multiply 3 by to get a 3x? We needed the x, so multiply it by the 1 on top. Here we say, what did we need to multiply x by to get a 3x? It was 3. So multiply 3 times 1 and get 3. Well, you cannot add x and 3 together, so you just write x plus 3 over 3x. You also might need to say that x cannot equal 0 in this case, because if it does, it causes the denominator to be undefined. So your final answer is x plus 3 over 3x, and x cannot equal 0. So in a problem like this, your common denominator, again, you wouldn't say you have x's in common. Now, if it said 3x without the plus between, you would have x's in common. But having a plus or a minus kind of messes things up. And you, in this case, would still just need to multiply your two denominators together to come up with your new numerator. So stop the video and go ahead and find what your numerator for both equations would be. So the numerator on the first one should be x, because if you say what times 3 plus x would give me this new denominator, it's x. And so whatever it is, you have to multiply by the numerator. So x times 1 is x. So here again, we say what times this x would give us this denominator? We need a 3 plus x. So if I multiply 1 times 3 plus x, I get 3 plus x. Then you're going to add your numerators. X plus x is 2x, and then the 3 comes down also over the whole denominator. Keep the denominator the same. Then to write your restrictions, you need to say to yourself, what would cause these denominators or this denominator to turn into a 0, which would make it undefined? If this x was 0, it would wipe out everything, and it would cause this problem to be undefined. So we don't want x to equal 0. Or if this x was a -3, 3 plus -3 would give us a 0 in this spot, and 0 times anything is 0. So our other restriction would be -3. On these other two problems, you may have learned this little phrase in elementary about keep it, change, this is division right here, change division to multiplication, and flip the 3 to 1/3, and then simply multiply straight across. So 1 times 1 is 1, x times 3 is 3x. So stop the video and do number 23. So number 3 would look like this. Keep the 5, change division to multiplication, flip the fraction. Flipping the fraction is called writing the reciprocal. So write the reciprocal and then multiply straight across. So the final answer is 5x. Then there is one problem below here that's a combination. You still need to keep it. Well, first, I think I would find the answer to this, simplify this like we did in 20 and 21. Find that answer first, then use your keep it, change it, flip it principle. So that will be it for this video, and finish up, and then you'll be able to check your answers before you take the little mini test.